Hello, everyone. What I want to do is go over homework 8. Just bear with me a second. I gotta get my microphone untangled. Okay, that's much better. Yeah, so I want to go over homework 8. The scores were not so great. A lot of people seem to really be confused and didn't pretty clearly didn't look at the examples that I gave for you guys um, on the hints. So definitely worthwhile to go over. And oddly, plug in the calculator and it is already um, formatted. But anyway, okay. So yeah, 40-year, $300,000 mortgage, monthly payments 6%. So I actually haven't looked at where where interest rates kind of wandered to recently. I should check out what the average interest rate on like a 20 or 30-year mortgage is. But anyway, so $300,000 loan. Remember, mortgages are just loans, period. So this is the present value. Right, so we don't know what the payments are. Let's call them K. It's 40 years, so 40 times 12 is 480. As we've done many times before. Just looks a bit weird. So as we've done many times, you take I-12 over 12, 0.06 over 12 is 0.005. And we have the calculator. If you've watched the videos, you know how to use it. So I was a little perplexed. People wrote down kind of annuity formulas and showed that. I would emphasize at this point using the calculator to quickly do these calculations because, well, that's the whole point of the calculator is to do. I mean, in this problem, you need it to find I-12, but even like throughout this problem and other problems from now on, and particularly in this homework, use a calculator just to do calculations quickly. That's really the point. So 6% over 12 is 0.5% clear TVM. So that's the interest rate, 480. And 300,000, make that negative. Or if you didn't, then the payment would be negative. So 1650, 64. So I have it all here, so I'll just save it. I don't really need to save it necessarily, but all right, so the new payment is 1650.64, and we want it to be 20% less. So just subtract off, well, 20% of this. Same thing as saying multiplying it by 0.8. 1 minus 0.2 is 0.8. So this is 1320. Actually, yeah, I do. I do need this, so no harm in just storing stuff. So we call the payments, store this here. All right, so we want to refinance, so we got to figure out how much we even owe in the first place after 10 years. 10 times 12 is 120. So it's my K. Let's write it down. So we do have a constant payment, constant interest rate loan. So we can use our little shortcut formula. So as I said, if you just want to stick with the other formula, that's fine. not going to lose much time, or it's not going to eat away much time. But yeah, so I have the actual payment here. So so this is going to be my payment, 480 minus 120. So I did 80. I'm not sure what happened there. Sorry about that. So that makes a lot more sense. 360. 0.5 interest, compute present value. Yeah, and this makes sense. It's only 10 years into the loan. You're paying off interest largely in the first chunk of time of the loan, just roughly speaking. So it makes sense that this is a little bit lower than $300,000 original loan amount, but not much, because you're really just not chipping away all that much at your principal this early on in the loan. Kind of depressing, but you know, thus is life, I guess. So typically, your house value goes up. So I mean, it's kind of that, the fact that you're paying so much in interest is offsetted by, your home value hopefully going up. With the baby boomer retirees kind of going to be flooding the housing market, or maybe not flooding. I've read it's going to be like a little bit of like, the next 10, 20 or whatever years, just a steady bit of increase in supply. Who knows if house prices will really go up all that much in the future. But anyway, it's for a different course on where to invest. Okay, so this is how much I owe, 275, 313. Right. Yeah, as I think I've said in prior solution videos, I personally like to write numbers down for exam FM, just so that it just helps me, avoid. It just helps me remember what numbers associated to what is, like this 275, 313 is my outstanding balance. The 1320 is my new payment. But yeah, so but you don't really have to do that. You can just use the memory keys. All right, so this is 5-1. So this is my new payment. It's a 30-year mortgage. That's what we're saying. So 360 monthly payments. We don't know what my monthly interest rate is. That's what we're trying to figure out. So yeah, a lot of people wrote down the formula and approximately J equals. The point of the problem is use the calculator to get this. That's why. No, this is why people paid, I think it was something ridiculous like $500 for these financial calculators when they came out. I forget when. I think it was in the 80s. Because you can do these calculations, these very, very practical calculations, just snap your fingers. Okay, so this is the present value. Which one is which? So this is the payment. So I made the present value negative, so we're going to make the calculator happy. All right, so J is my monthly interest rate, 0.0033654. If you want to keep it as 0.33654%, that's fine. So I-12 is 12 times this. Again, I don't care if you give your answer as a percentage or a decimal. I'm happy either way. As a percentage, 0.040385, 4.0385%. That's the interest rate you want if you want a 20% reduction in your new mortgage. All right. So yeah, good practical problem. I like these problems because they're just so damn practical. I mean, figuring out what new mortgage interest rate you want. Yeah, it just you don't get more practical than this, in my opinion. But anyway. All right, sinking fund problem. So you are loan 100,000, pay this off one of two ways, constant payments of K at the end of each year. All right, so let's just immediately do A. So this is saying 100,000 is KA 10.06. So clear TVM. One thing I've mentioned before, if I haven't, you can often get away with not clearing the TVM, but it's not always clear when you can get away with it and when you can't. And the last thing you want is to be on exam FM and be confident that you know how to do the problem, because you probably can do the problem, but you didn't clear the TVM and you get garbage answers. That's just going to throw you off, make you panic. Not a good time. So just clear, when in doubt, clear it again. It does not waste that much time re-inputting stuff. It really doesn't. That's just my opinion. So, all right, easy peasy. I think I'll use this. So 13,586, 80. Let me just shut the door here. I'm in my office. Probably the only one here, but that is okay. All right, so the point here is you want these two schemes to basically give you want these two schemes to be the same. You want to pay the same amount using these two schemes. Right. Yeah, and you want to figure out what the sinking fund interest rate is. Okay. So you can set up the formula. If you don't even want to use this formula, it's really not a big deal. I guess I'll do it both ways. But just using the formula strictly speaking, so when we have constant payments into a sinking fund, and we do, because I'm telling you we do. So this, and again, I'm going to use what I stored. Second. So the formula is it's the loan amount, the loan interest rate. I'm telling you is 0.07. So this is your interest payments you got to make. And this is the payments you got to make each, or rather, these are your interest payments, and these are the payments you got to make each year to have 100,000 after 10 years. Okay, so yeah, I stored this. I'm sure I did. All right, so just do minus 100,000 times 0.07. All right. Divide by 100,000. Do 1/. All right, so 1518 is S10. And this makes sense. S10 is going to be around between 10 and 20 because it's the accumulated value of $1 payments at a reasonable interest rate. So at least this makes sense. And N1 payment, sorry. So I'll make the payments negative because I could have just, oops. Could have made this, okay, I definitely screwed this up. So let me just do this again real quick. Forgot to store things. So yeah, good to store things, because if you screw it up, then Yeah, so I'm just solving for S10JI. I trust that you can do that. That's 1 over. Store it in a 2 spot. All right, so let's clear TVM, make this the future value, 1 payment, 10N, compute interest rate. So kind of a high interest rate, 8.98%, 0.0898. I mean, if you don't even want to use this formula, that's fine. So right, so if you don't want to use the formula, so your interest payments are, well, 100,000. 0.07 is 7,000. This is going to be your 13,585. Because we're saying we want these two schemes to be equal. So in the first one, this is what you're paying each year. So we want also to pay this each year. All right. But you have 7,000 in interest. So 1 minus 7,000. So this is what your sinking fund payments are. I'll store that in the 2 spot. 6,585, 80. All right, so you need 100,000. It's going to be 6,585, 80. S10. Sorry, that's an S. All right, so that's the payments. 100,000 negative future value, 10N. And we should get the same answer. Of course you do. Yeah, I mean, so the only reason why you might not like to or want to use the formula is because the formula only applies when you have constant sinking fund payments. If they're not constant, you really just have to use this kind of reasoning, and that's the entire point of the next problem. Okay, so we have a $200,000 loan, interest rate, loan interest rate 7%. And we're just describing in the first sentence the sinking fund method. You pay off interest payments at the end of each year, pay the principal off in one lump sum after the end of 30 years, accumulate the 200,000 by making deposits at the end of each year into a sinking fund, earning 8%. Total outlay is 1.25x each year for first 10 years. Then for the next 30 years, it's X. All right, so let me draw the sinking fund time diagram. So TD for time diagram. So yeah, so let's do this. First 10 years. So we have 1.25 x equals my interest payments, which are always going to be, so remember, you only just pay off interest. You never touch your principal. It's 200,000, 0.07 plus your sinking fund. All right, so what this means is if you subtract, so let's just do that. Your sinking fund payment for the first 10 years is 1.25x minus 14,000. That's the interest payments you're making. So you never touch interest, so each year you owe 14,000 So you better be putting that 200,000 to good use, because because of this loan, you are having to pay 14,000 each year in interest. That's yeah, that's painful, but hopefully you're not buying a boat or something stupid with it like that. I mean, not that I personally love kayaking, so huge kayak fan. Guess if I had more money, I would buy a nice, really nice boat and throw it on like Saratoga Lake or Lake George. That would be nice. But anyway, all right, 1.25x minus 14,000. Yeah, for this problem, I would definitely draw a time diagram because a lot of people just screwed some weird things up. I guess some people did really weird stuff here. I don't understand. Like I was confused, really confused as to the reasoning that some people employed. So the next 20 years, a total of 30 years. Right? So it's the same thing except X. So I'm not gonna go through the whole thing again. But literally the same thing except yeah, except it's X is the total outlay each year. So X minus 14,000 is my sinking fund. So yeah, we do not have constant sinking fund payments. We have constant sinking fund payments for the first 10 years, then it changes. So here it's X minus 14,000. X minus 14,000. So, right. Okay. So let me. All right. So this time diagram has to accumulate to 200,000 after 30 years. That's kind of the whole point. So this is going to be, let's do the first 10 years, 1.25x minus 14,000. So this accumulates to, these are my payments, S10.08. The sinking fund earns 8% interest. And this is going to sit in the account for 30 years. I think do this here. So I'll do it right here. So from 10 to 30. So the accumulated value formula gives me the accumulated value at the end of the last payment period. So that's 10. So from 10 to 30 is 20 years. So if I had to guess, growing by 8% each year for 20 years would be maybe having 5 times the amount you start off with. So let's see, $1 grows to yeah, so it's about 5 times, 4.66 times. So whatever this is, multiply it by roughly 5 is what it accumulates to at the very end. So if you forget to do this, that's a big deal. We're talking a lot of money you're missing out on. Right. And a lot of people put to the 10th, which I don't understand, because it's 10 to 30, not 10 to 20. It's a 30-year, you're paying the lump sum at the end of 30 years. So please draw the time diagram. You know, I was still a little lenient in this homework, but I start drawing time diagrams. I think it'll make more sense. All right, so this is the accumulated value of the first 10 payments in blue, and again, from my perspective, really nailing down these annuity problems, basically, it's just easy points on exam FM. Those are basically like loan thinking plus annuity stuff. So yeah, these are just 20, 11 to 30, inclusive is 20 total payments. Vex minus 14,000, and the last payment is at t equals 30, so you do not have to multiply by anything like you do here. Like I did 1.08 to the 20th. So it is x minus 14,000 s 20.08. I trust you can do all this in the calculator. If you want to use a formula, fine. I think it is easiest to use the calculator. Yeah, I mean, so x is going to be 13,720 and 93 cents. So probably what I would do is I would probably kind of distribute in my head and kind of get all the numbers to the left-hand side, and then get all the constants to the right-hand side. So what do I mean by that? 14,000 payment, 10 and 8 interest, compute future value 202, 811, 8745 times 1.08 the 20th. Store this in the one spot. Make sure I did this right. Big number, but it's fine. Right, okay. So this. All right, so do this one here. So plus 200,000. So yeah, we got this astronomical number 1,785 964 956. Okay, so what's in front of the x? Well, it's 1.25 S10 0.08 1.08 to the 20th plus S20.08. Let's get this number here. It's x times this whole thing. Okay, so let's quickly, we could do 1.25 payment, 10 and 8 interest, compute future value. Not sure what happened here, but do it again. It's getting annoying. There we go. Okay, times 1.08 to the 20th. Store it in the 2 spot. 20n 8 interest 1 payment plus this times this number here, and you get the same answer, 13,720.90. And if you want to just write some more stuff down than just kind of what I did, like if you actually want to distribute, I mean, if you can't do this in your head, the distribution, then just basically write one more thing down where you distribute everything, not that much writing, and then do everything in a calculator. But yeah, up to you. Either way, this is where 13,720 comes from. Okay, four. So, yeah, so, all right, so you have a 20-year loan that you can pay it off normally, or you can pay it off using a sinking fund where, so remember the formula for the sinking fund payments with constant payments, that's a formula to, like here, that's a formula to give you exactly the correct amount to pay off the loan entirely. Here, I'm telling you, we're going to have a prescribed payment, which is basically the same payments, we're going to have a prescribed total payment using the sinking fund method. So, sinking fund deposits plus interest payments is going to be the same thing as kind of paying it off in the usual way. And by that, I mean, we pay this loan off in the usual way. We have payments of P. So P is also going to be sinking fund deposits plus interest payments, because payments into the sinking deposit are P minus the loan. That's kind of the point of this problem. I think I mentioned that in the example when I did it. We're getting we want these two schemes to be the same, but if we do that, it's just going to be, you're going to have extra at the end of 20 years. Right? So how much is that extra? Right. So I do these before I put this up. So if I tell you you're going to have extra, you are going to have extra, and if you don't have extra, you did this wrong. Or like in the next one, and a lot of people did this. I was really surprised. If I tell you that you have one final smaller payment, you're going to have one final smaller payment. So if you get something that's like massive at the end, way more than 250, you did something pretty darn wrong. Again, I do generally check these to be correct. So anyway, paying this off kind of the usual way. So 20,000 is PA 20.08. Dump this in the calculator, no reason not to. $20N8 interest, and as always, does not matter what order you do things in. P is 27,0441838. Okay. Okay, so for the second option, your interest payments are simply, again, you never touch your principal of 20,000. So the loan is the loan is 8%. The interest payments are going to be just 8% of 20,000. which is 1,600. Okay. So your sinking fund payments, again, the whole point here is that your total payments are going to be P here. 1,600 is going towards your interest payments. P minus that is going towards your sinking fund. Or sorry, your interest payments are 1,600. P minus 1,600 are your sinking fund payments. So add the two up, you get P right here. P being $2,037.04. So these two schemes are going to be exactly the same. The total amount each year going towards the loan is $2,037.04 each year. So 2037.04 minus 1,600. 437.04. All right, so what do we have after 20 years? It's this 437 S 20.085 payment 8.5 interest 20N compute future value 21 14289. All right, so what is left over or what is extra? Well, you need this accumulated value to pay off for 20,000, so just subtract by 20,000. So you got something nice. You can, scheme B, particularly, these two schemes result in the exact same total outlay each year towards the loan, which is $2,037.04. But because you were lucky enough to find an investment that earns a little bit more than the loan interest rate, then the sinking fund method is nice because you're left over with $1,100 roughly. You can spend that on something nice. I don't know, whatever the hell you want to spend $1,100 on. Yeah, I don't know. Definitely can't get a particularly nice boat with that little amount of money, but all right. Anyway, so last but not least, number 5. Yeah, I saw some weird stuff in number 5. All right, you borrow 50,000 at I-12's 3%. I'm telling you, you have monthly payments of 250 and one smaller payment 1 month after the last 250 payment into a sinking fund earning 3.6%. Makes this work out nicely. When the sinking fund reaches 50,000, excuse me, you deplete the fund. I should have put the word to. Sorry, that was a little weird. That typo, I missed that typo. I apologize if this was confusing. You deplete the fund to completely pay off the principal. So nothing new. It's just normal sinking fund explanation, basically. Find a total non-time value amount paid over the course of the loan. You might, occasionally do want to know time valued, non-time valued rather, how much you paid. Usually don't, because You guys are smart people. You're investing your money into something. And still, if you don't know, if you have some money laying around, you can right now certainly invest it in short-term bonds. If anything, like I have my money invested in the Vanguard short-term bond, a short-term kind of fund. That's earning like 5%, something like that, and it's 5% risk-free is pretty nice. So I mean, the stock market you see every now and then it's basically just hitting new highs. So um, tough to argue putting it into the stock market. Just grows and grows and grows. Just never stops growing. It seems it's pretty amazing. But anyway, okay. So remember the first task, just like in the example, is to find n. So you set 50,000. You have to accumulate to 50,000. I'm telling you the payments are 250. And the sinking fund interest rate is 0.036 over 12, 3.6% over 12, 0.3%, 250N. Make this 50,000 negative. I'm not sure what I did wrong there. It's been a long day. So let's just re-input stuff. Have the calculator on, that would help. 250N, 0.3 interest. Did I really do that? Yes, I did. This is the payment. Again, sorry, it's a long day. Hopefully you will take exam FM when you're a little well rested, a little more well rested and fresh. Otherwise you're in for a rough 3 hours. Though the adrenaline does kick in and you're kind of like hyper focused. So not recall, compute, and 156.90. So we want to round down because I'm telling you that you have 250 payments and one last smaller payment of less than 250. So if you have 157, then this is, let's see, 0.3 interest, 250 payment, compute. You have more than 50,000 at the end. Okay, so I'm telling you the scheme is you have 250 payments and one last smaller 250 payment. All right, to exactly reach 50,000. Here you're reaching more than 50,000. So here's the time diagram. Sorry, did I say one? I meant 156. Right, so this is the number of 250 payments we have. I don't know, let's call this okay. I don't know what we call this, doesn't matter. Okay, so you gotta be a little careful. So this is 156. Some people just did like 156 times 250. You're dumping this money into an account earning 3.6% nominal semi-annual. So that means we're dealing with accumulated values here, or annuities, accumulated value. It's like this 250 sits in the account for 156 months. The next one would be 155 months, et cetera, et cetera. So it makes no sense to just multiply 250 times 156. Money in this scheme accumulates, it earns interest. It's like an annuity. It's like an annuity earning interest, and we're taking accumulated value. We've done that many, 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 many times before. So, but what you got, that's not what you have to be careful about. I mean, that's just, if you don't understand that, then you need to get up to speed. I mean, to be honest, that's just the bottom line. But this here is the accumulated value at 156, and then it grows by 0.3%. Not a whole lot, but still not nothing. It still does grow by 0.3%. And remember, like for a teacher's fund, if you have something like the New York State Teachers Fund, I mentioned SUNY Albany, the New York State teachers pension rather hires a lot of SUNY Albany students as actuaries, and that is a $8 billion fund. So let's just say 10 billion. It's 100 million billion. Can't even. All right, let's just end. Yeah, sorry. 1 second. Yeah, let's do 8 billion here. So let's say, let's not even do that. Let's just do 0.3% of 8 billion. Kind of really want to emphasize this point. That's still $24 million. That's not nothing. I mean, relative to 8 billion, it's not a lot, but it's still, I don't think anyone would say $24 million is just nothing. So yeah, the point I'm trying to make is, this little, what seems to be a pointlessly little thing, if you forgot to do this for the New York State Teachers Fund, pension fund, that's a $24 million error. Okay, you don't want to make a $24 million. That's all I'm trying to say. Okay, so anyway, all right, 156N, 0.3 interest, 250 payment, compute future value, times 1.003, 4963, yeah, sorry, 788.84. This is how much you have at the end. Sorry. And then you have the K. Yeah, just do that in green. Sorry about that. I forgot the K. That's at the end, so it accumulates nothing in interest. So just simply, this has to be equal to 20,000. Sorry, 50,000. I have no idea why I said 20,000. Maybe I had 20,000 last year. I don't know. But it's 50,000. Yeah, it would make no sense. All right, so oops, okay. Two 116. So small, so it's smaller again. The point is here this is smaller than 250. I checked it before I put this up. So I mean people got like 30,000 equals K. It's not smaller than 250. So he did something wrong. At least if you do something that wild, or get a wild answer like that, you know he did something wrong, and it would be clear on Exam FM something's really off. That's good at least. Okay, anyway, so let's finish this thing off. This is getting long. So total, you have your you have your 156 payments of 250. You have your one payment of 211.16, and you have 157 payments of interest. So you notice we've never even used this yet. But now we're going to do it. So yeah, this is my total sinking fund. Oops. Here, let me do it like this. So 125 times, sorry. And I didn't say that. So they have 157 payments of interest, and it's well, 0.036 over 12 is my monthly actual monthly interest rate. Sorry, 0.03. Second. Yeah, 0.03. Sorry. So you have 157 interest payments, and each interest payment is so we have 3 over 12, 0.25% of 50,000. So it's times 0.0025. Each one is 125. So we have 157 payments of 125. So this is my total interest payments. All right, times 157 plus 250 times 156 plus 211, 58,538. 58,36.16 is the total. So yeah, unfortunately a little long here, but it just takes time not to do these problems necessarily, but to explain what is going on here. And I'm worried that the sound is not working here. It better be working, or there's going to be some issue here. But anyway, all right. End is near, end is in sight. So long, take care, and yeah, only one more week. All right, yeah, have a good weekend. Bye-bye.